here's most important thing for today, and then I want to practice some other stuff as well. Presenting the formula sheet. So how about your formula sheet? And I'm going to talk through a couple of these and have you practice them as well. So I'm going to kind of indicate the ones that are important. Really, there aren't a ton that you will need to, a ton of formulas on here that you'll need to specifically use. So there are a lot of these that I'm going to say, okay, we're not really going to use this, but just in case. So this is a formula for how to find the mean. You know how to find the mean. This is a formula for how to find the standard deviation. Usually the calculator is just going to tell you these things, or the problem is just going to tell you these things. But there is a formula. Here it is. This is my y hat equals a plus bx. I hope you know that. This is a couple other things for regression that you're probably not going to need. For how to find slope, how to find r. Again, usually the calculator just tells this to you. Probability. These two are pretty important. Ooh, that's way off. All right. These two are pretty important. Probability of A or B being the probability of A plus probability of B minus probability of both. And then the conditional, A given B, is out of all the times that B happens, how often does A also happen? Then we have our binomial and geometric distributions. And these are the formulas for those, including mean and standard deviations for binomial distributions. Okay, so that was, that's all the first semester stuff. So I'm going to pause there and then see what questions people have before I move on to the second semester stuff. All right. Here are the confidence interval and the test statistic. This is the structure, the format for every single confidence interval formula and every single test statistic formula in order to get the p-value in the hypothesis test. This is the outline that you can use for all of these. And then what they're expecting you to do is fill in the pieces for that specific distribution. Okay, so I'm going to do one for a particular confidence interval and then let you practice one to make sure you can get the structure and the formula. And I said at the beginning of all this to practice familiarizing yourself with that structure and knowing how the pieces fit into that structure rather than trying to memorize about 10 or 11 different formulas for all the different confidence intervals and hypothesis tests. They're all basically here. And then here's the chi-squared one, which is separate from the other ones. So for example, let's take and do a one proportion Z interval. One proportion Z interval. To do a one proportion Z interval, well, first off, since it's a confidence interval, it should be using this format. So it should have the plus or minus in it and all that. So sometimes I see some people using a confidence interval structure when they're trying to get a p-value, or using trying to get a z-score when what they want is a confidence interval. So make sure you're using the right format for the thing that you're doing. That's thing number one. So we're using this confidence interval format. The statistic plus or minus critical value times standard error. All right. So for a one proportion Z interval, first off, our statistic, or I've seen some questions call it a point estimate. Our statistic that we're estimating, if we're doing one proportion, then we're using P. So that means that our statistic is going to be P hat. Well, so far? Yes. Then plus or minus our critical value. Since we're using proportions, what should go in for our critical value? Should either be a z-score or a t-score. It's going to be a z-score since we are using proportions. Remember, t-scores go with means. So that's going to be a z-score times the standard error of the statistic. So times, where do I find standard error? Well, here is one proportion. Here is the standard error. Let's put it in. There's our formula for a one proportion z-interval. That's how it gets built. Okay, so I want to give you a minute to try and make sure that you can understand how this works. This time I'm going to use a hypothesis test instead of a confidence interval. So I want you to try and do one for a one sample t-test and see if you can build the formula. So on this one, we're using t-scores, and we're using this format for the test statistic, statistic minus parameter over standard error. So our statistic, since we're talking about estimating for means, our statistic would be x bar. That's the mean of the sample. Minus, what usually goes in this spot is whatever the hypothesis says, whatever the null hypothesis says. So in this case, mu naught. So mean of the null hypothesis, whatever a null hypothesis says the mean is. So when we get into like two proportions or two samples, a lot of times what goes here is 0 because our null hypothesis is that the mean difference is 0. And then over our standard error, and if you look down for one sample means, our standard deviation formula is S sub x over square root of n. So that's what your formula should look like. Okay, let me do one more, just so that you see how the pieces fit together. Two sample t interval. And again, I'm not just showing you what the formulas are and having you memorize them. What I'm trying to do is to help you see how you can use the formula sheet to basically have it feed you the formulas piece by piece. That's what you should know how to do. I mean, if you want to try and memorize 10 different formulas, then I guess have at it. But I think this is the easiest way to do it. Two sample t interval. So first off, since we're using two samples, then the thing that we're estimating that goes before my plus or minus should be the difference between the means. That's what we're estimating. Plus or minus, since it's a t interval, we're using t-score. And then since we're using two samples, let's go down to two samples for means. There it is. So this square root of s1 squared over n1 over plus. This is basically adding the variances since we have two different means that we're adding together, or that we're subtracting. Subtract the means, and then for standard deviation, we add the variances. But the big thing that you need to know is that this piece plugs in to this part of the formula. So this whole thing needs to be laid out when we do the confidence interval. The most common thing I've seen people do as I've looked at people's free responses is that they just put the standard error part into the formula. Make sure that the whole structure is in whatever formula that you're using. So then for hypothesis tests, that would become, this would be on the top of the fraction, and then minus whatever a null hypothesis says, which will probably be 0. And then this square root thing goes at the bottom, on the bottom of the fraction, because it's the standard error of the statistic. And then if you want some more help with that, then come talk to me outside of class, and we can practice a couple more of those and show how, if that's still not clicking into place for you. Because I want to go over some other calculator stuff today as well. First off, normal PDF, don't use it. We never use it. We'll use binomial PDF, but not normal PDF. We're always going to use normal CDF instead. And then we also, our other tool that we have is inverse norm. Those are the two different calculator commands that we have. So first off, normal CDF. Normal CDF, you are, and go to normal CDF on your calculator so that you can verify this for yourself. For normal CDF, I want you to think about what is the input? What are you putting into normal CDF? And what is it giving you out? So in normal CDF, what are the things that it's asking you for? What are the things that you're putting in? Lower and upper and mean and standard deviation. So the input is range of values. In other words, lower, upper. And it tells you what? When it gives out an answer, what is that answer telling you? A proportion. It tells you proportion in that range in the normal distribution. So if you want to know about a percentage or a proportion or a probability, if that is what you're trying to find, then normal CDF is what you want to use. Same for t-scores, by the way. If you want to know a percentage that's in a certain range for t-scores, that is t-CDF. Inverse t is the, you guessed it, it's the inverse of that. It is the opposite. So for inverse norm, it's going to prompt you for area. So you're going to input an area or a proportion or a percentile. That is the thing that you're putting in. So if proportion and percentile or the probability is the thing you already know, then you're using inverse norm. And it will tell you the value at that percentile. So the area, the specific area you're putting in is the area to the left of the value. So, as an example, let me give a couple of questions, and let's make sure we know which one we're using here. So let me bold these here. So I'm going to give a couple of examples of types of questions, and you're going to tell me which one you're going to use. All right. Let's say that, you know, I have a distribution of like test scores, and I want to know what % of people scored at least 20 on the test. Is that going to be normal CDF or inverse norm? It's going to be normal CDF because we know the values, at least 20. So we're going to put 20 as my lower and really high number as my upper. And it's going to tell me, the question was what %? So it tells you the proportion in that range. So another one that's is like, what is the probability that we fall between these two scores? How about with confidence intervals? So we want the critical value for a 95% confidence interval. Either way. It's inverse. Inverse because we input the area that's to the left. We put in, so an example, examples of things that inverse norm will answer. Critical value in confidence intervals is what inverse norm can help, because that means we have the middle % of data, and then we add a % on the tail. But we are putting in a % and getting out a z-score or t-score. Another example of a place where inverse norm is useful is, what is the x percentile of the distribution? So you put that question in as your area, and then you get out the z-score there, and then you can solve for the value using the z-score formula. Or if you have the mean and standard deviation, you can put in the area, put in the mean, put in standard deviation, and it'll tell you what it is. But overall, it is, I have this area, I have this percentage, I have this percentile, I want the value, or I want the z-score.
So doesn't inverse norm give you z-score and then inverse t gives you t-score?
Yes.
Okay.
Inverse t would give me a t-score. So correct. You cannot get a t-score from inverse norm. So if we're dealing with means, the overall idea I wanted to get from you is that we're using inverse for the confidence interval step. So inverse t if we're using means, and then inverse norm if we're using z-scores. If we're trying to get a z-score out. So examples here. If it asks something like what % or what is the probability? That we are larger than this amount, or what % of values lie between this and this, lie between 10 and 20. Those are all questions that normal CDF will help us answer. How about another question I've seen them ask? What is the interquartile range of the distribution? Is that a question that we should do normal CDF? We have the values and we just need percentages? Or with interquartile range, do we already know the percentages and we want specific values to get out? We know the percentages because the percentile for Q3 is 75th. The percentile for Q1 is going to be 25th. So we know those percentiles and we're trying to get out values. So another place that inverse norm gets used is IQR. And the comma goes over. Yeah. I wouldn't put the comma. There we go. Okay. All right. All right. Any other questions on the use of inverse norm and normal CDF. So remember, normal CDF usually lower than upper than mean and standard deviation. Inverse norm. One more thing to say. Remember that putting the calculator command by itself is not enough to get you credit on those kind of questions. You should also show, either draw a picture or saying I'm using a normal distribution with this mean and this standard deviation. Calculating out the z-score can get you credit. But if you just have the calculator command by itself, that's not enough to give you full credit on a free response question.